Hey guys, I want to go over with you how to fill this out, and then after I go over this and we fill it out together, you'll just fold it and label it and put it in your science notebook. When you are answering questions about a motion graph, the first thing you have to do is look at these axes and see what kind of graph you're dealing with. You have to look and see, is it a distance time graph or is it a speed time graph? Notice this one has speed. Now, you might, instead of the word speed, remember that you might see the word velocity. We tend to use those, but just spelled that wrong. We tend to use those interchangeably. That's an I in there. So whether you see velocity time or speed time, that's going to be this graph over here, okay? So when you look at these, what you notice is the pattern is exactly the same on both of these, but they sure don't mean the same thing, right? So this is going to be segment 1 from here to here on both graphs, and what we're going to do is compare what's going on, and we're just going to write it down here in the table. We're just going to kind of make a brief summary of what's going in each one, okay? All right, on a distance time graph, here's the first segment. When I see a straight line like this, it means that the object is moving away from where it started at a constant speed. So I'm just going to put that right here, okay? So the object is moving away at a constant speed. And remember, I can calculate the slope of that line. If you wanted to, you can calculate the slope of that line, and it's going to be the same at any point along the line. There we go. Here we go. And if I wanted, I could calculate the speed right here. Speed is distance divided by time. Well, the distance, it went 20 meters. And it did that in 10 seconds. So speed is equal to distance divided by time. It would actually be 20 divided by 10, which is 2. And I know it's a constant speed of 2 meters per second right there. But let's go over and look at this graph. This time, I have speed right here and time right here. So let's think about what's going on. Right here, I can see that it's just whatever this object is, this is showing me that it's just speeding up. It's going 10 meters per second right there. And as I keep moving up, it's going 20 meters per second by the time I get there. So on a speed or velocity time graph, that same line is now showing me that whatever object it is, it's speeding up. So I'll just put object is speeding up. It started, looks to me like it started at 0, and now it's going faster, 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 faster. Okay, pretty cool. All right, let's look at the next line segment. Okay, push it down a little bit more for you. All right, so the next line segment, I'm going back to my distance time graph. It's going from here to here. And again, that just means whatever object this is, it's moving, it's continuing to move away from where it started. I notice that this line is not as steep as this line right here. So it's moving away from where it started. It's still at a constant speed, but it should be a little bit less of a speed than this. And we'll calculate that. I'm going to go ahead and calculate it just to double check. I'm starting at 20, and I'm going to 50. So that's a difference of 30 meters. And speed is distance over time. I started at 10 seconds, and I went up here to 40 seconds. 40 minus 10 is 30, and 30 divided by 30 is 1 meter per second. And that makes sense, because I can look at this and see that that is not as steep. Okay, so I'm going to go down here, and for line segment 2, I'm going to put the object keeps moving away. At a constant speed. If it's a straight line like that, it's a constant speed. Okay. And again, you could make a note that it is going slower than segment 1. Okay. All right. Now let's go back up here. Same line segment. I want to look at what's going on from there to there. That's line segment 2. And again, now I have a speed versus time. So it's right here. It's going 20 meters per second. Now it's going 30 meters per second, 40 meters per second. There's Miss Carrier out in the hallway. And all the way up, it's speeding up, and now it's 50 meters per second. So I'm just using these numbers, and I see that the object is speeding up. So I'm just going to go back down here. I'll put object is speeding up. And I think I might put speeding up from what to what. So I'll go speeding up. So at the beginning of that line segment, it's going 20 meters per second. And then I see it speeding all the way up to 50 meters per second. Okay. All right, so now let's go back and look at this third line segment. Okay. All right. So right here is the third line segment, right there. So what that means, on our distance time graph, at 40 seconds, we were 50 meters away. And it looks like maybe at about 45 seconds, a little bit more, we were still 50 meters away. So remember, this means not moving. Okay, not moving. So I'll just put not moving right there. If you want, you can put 0 meters per second, I guess. Come down here. It's flat line, remember? Not moving. All right, but now watch this. Okay, I'm putting this here because I know this is what a lot of kids miss. Okay, but now watch. If I come over here on the speed time graph and I look right here, this means something different. Right here, it's going 50, it's going 50, this is speed, it's going 50 meters per second because that's a speed, okay, 50 meters per second. Now this flat line means it's going 50 meters per second, it's going 50 meters per second, it's going 50 meters per second. That flat line on the speed time graph is telling me a constant speed. It's just telling me the speed isn't changing right there, it's staying 50 meters per second. You got to read the graph. So this one is where you can miss it really easily on a test. Guys, you have to slow down and look at what kind of graph it is. If it's a flat horizontal line on the distance time graph, it indicates the object isn't moving because its position isn't changing. If it's a flat line on a speed time graph, it means the speed is staying the same. It's constant. All right, here comes the fourth segment right here, line segment 4. And again, what this means on the distance time graph is that I'm coming back closer to where I started. My position is changing. I'm coming back at a constant speed. And I don't really know, let's see here. I'm going here to here. That's a little bit trickier. The distance is 50, back down. I'll try to calculate speed. I went from 50 to 30, so the distance is 20 meters. And the time is what I really can't, I would have to just estimate the time, guys. I don't know. Maybe 45 to 55, maybe 10. Not real sure. Maybe 10 seconds. So that puts me at 2 meters per second. Okay. So that's saying that that's about as steep as this is here. I kind of guessed on the time there. But I do know this, the object is moving back towards where I started at a constant speed. So I can put that down here. Hi there. We're just recording. Custodian's trying to be so nice for you guys and be all quiet. Okay, so now let's look over here though. Let me get this up. All right. But now I've changed and I'm on a speed time graph. So whatever object this is, it was going 50 meters per second, and now it's going 40 meters per second, and now it's going 30 meters per second. So this means that the object is slowing down. And it's not hard if you just stop and make sure that you look and see what kind of graph it is. If it's speed, it's just showing you that the speed is slowing down. So that's all I'm going to write over here. I'm going to put the object is slowing down. Okay. Again, it went from 50, and then it looks like it slowed down 50 meters per second, and then it slowed down to 30 meters per second. I hope that looks right. Okay. All right, and then again, we're at the very last one, so let's look again. Right here, I know that means flat line because the position isn't changing over time. But over here, I know this means a constant speed of 30 meters per second. Ooh, I feel like I want to write constant speed of 50 meters per second on that other one. I want to go back and add something. I'm going to put a constant speed, 50 meters per second. Just feel the need to add that on. Now I'll go back down here. I'll put not moving. But over here I'll put constant speed. And let me double check. Yep, 30. Okay, so I want you guys to notice you've got the same pattern on both of those graphs. You have to stop and look. Is it a distance time graph or a speed time graph? Once you get that done, you can just fold this over. I'm going to label it graph comparison. And you should glue this into your science notebook right with your other motion notes, okay? So you just want to put a little bit of glue back here, glue it in so that you've got that graph comparison. Okay?